Today, it is difficult to imagine a modern metropolis without running water and sewage systems. What do we know about the water we use every day? Where does it come from to the tap, and where does it go off to? We'll find this out today. First, river water is passed through a series of grids to weed out large and small debris, foliage, needles, and small fish. Then comes chemical treatment. This is the first stage of chemical treatment. In 1 hour, more than 20,000 cubic meters of water are treated with chemicals in this mixer. Chemical compounds are now in this water. They absorb various impurities from it, which are gathered on a surface in the form of these flakes. Now they need to be removed. Also, the water needs to be cleaned of the chemicals. To do this, it is settled and then filtered. It may seem that the water in these tanks is stationary. In fact, it slowly passes at about a speed of 4 meters per hour through a layer of sand. After that, the water becomes drinkable. However, before sending water to the city, it is chlorinated and tested in the laboratory for more than 180 indicators. When we were preparing for filming this program, we planned to take samples directly in the channel in front of the water treatment station. But it turned out that there is absolutely no need to do this, because in this chemical bacteriological laboratory, there are water pipes that deliver water from the pond, as well as from all stages of water purification up to the final one. Do you see the difference? Now we'll check how river water differs from tap water. Elena Vladimirovna, well, you can see with an unaided eye that this water has a yellowish shade. Yes, this one is absolutely transparent. How is this water different from that which comes from the tap?
Well, it has organic substances, and these are the metals that it contains there. These are suspensions of a natural origin. These are clay compounds. Therefore, all this must be cleared.
Chlorine is a stop sign for all people who say that you cannot drink tap water.
If we don't provide the presence of chlorine in the water, then this doesn't ensure its sanitary reliability.
Now we have selected a sample here for you. Can we test it right now?
For chlorine residual.
Yes, for chlorine residual.
Yes, of course. We add potassium iodide, add a buffer to maintain a certain pH medium. A yellow color appears, which...
Yes, I can see that.
Yes, it's the equivalent of the chlorine content in the water. Then we add the indicator starch. It has a strong coloration, which says that there's chlorine in the water.
So far?
We add a titrant, which just contacts the chlorine that is in the water sample. Judging by this content of milliliters, which we took for titration, we can say that the chlorine residual is 1.1 in the drinking water.
But what's the standard?
The standard for drinking water is 0.8 to 1.2 milligrams per liter.
So that is, this water is absolutely fine?
Yes, its quality is absolutely normal.
It can take up to 1 day for water to get to apartments. And if it were not for sodium hypochlorite, which is added to it before being sent, an epidemic would take place in the city. In pipes, it does not allow microorganisms to develop while retaining water in drinking capacity. But the water's taste and utility also depend on the state of the city's pipeline. Russia stands as one of the first places not only in the length of the networks, but also in their deterioration. 7.5 thousand miles of pipes and utility systems, and this is the responsibility of Wastewater Canal. So how to manage all this gigantic infrastructure? This is the central dispatch office of Wastewater Canal. All information about network operation flows here, and the work of emergency teams is coordinated in case of malfunctions. And only 4 people cope with all this huge number of tasks. Numbers on multiple screens show comprehensive information about the operation of the entire system. According to their values, dispatchers can determine the place of the accident and change the quality of water throughout the entire multi-kilometer network. Well, with a couple of keystrokes, they can also turn off the water supply of entire areas, but it usually doesn't reach this point.
Hello. Yes. Vera, we have a deviation from the norm in Chertanovo. Do you have any notices on failures or leakages in the street or somewhere around? No? Then send a team to the address Chertanovska 30. Check all the utilities nearby. Send the information here.
On Chertanovskaya Street, in one of the highways, the pressure fell. However, the residents won't even notice this. The water supply immediately switches to the reserve branch of the pipeline. A team of specialists is sent to the place of emergency. Together with the Wastewater Canal emergency team, we are going to their next challenge. What could have caused the Chertanovskaya accident? You, as I understand it, are like special forces of the water service company, right?
Well, you could say that.
Pipes get out of order mostly due to their dilapidation or some external damage.
Builders can break them with an excavator if they drill somewhere there. So because of this, an accident occurs. Well, there are cracks from time to time.
On the spot, it turned out that it's so easy to get to the right pipe. The well was flooded with meltwater. First, it needs to be pumped out. In each emergency vehicle, there is a water pump for this. After the access to the pipe is provided, it is possible to determine the cause of the accident. Only it won't be done by a person, but by a self-propelled tele-robot. The operator manages it from the car, receiving the image from the camera in real time. Telediagnostics allows you to determine not only the place of leakage, but also its cause immediately without excavation.
We see that here's a small crack.
So you now basically have determined the place of damage.
Yes, we're taking the exact footage. Then we dig the area and weld this crack to eliminate the leakage.
Cracks are the results of pipe corrosion. They are holes through which water flows outside. Water pipelines in our country consist of 90% of metal pipes. The majority need repairing and even replacement. And here is another method that allows you to carry out scheduled and even emergency repairs without extensive earthworks. Stanislav, when there is a need to change the pipes, but no possibility because there are buildings, roads, some other utilities, there is no possibility to dig a large pit and remove the pipe. Do you also have a method that makes all these inconveniences work around possible?
Yes, there is a method, the polymer coating Scotch coat. It allows us, without opening the tube, to spray the coating on the inside, which restores the inner surface of the pipe.
But after the polymer coating is applied, corrosion in this pipe is no longer possible, I guess, correct?
Yes, it completely stops because the coating prevents from entering it, and corrosion doesn't occur on the surface.
Such a fast-setting polymer doesn't just return the working quality to old steel pipes, but also makes them as durable as modern polyethylene ones. One of the most difficult stages is over. The hose through which the polymer components will be delivered is inserted into the pipe, and now a machine is attached from that side, which will pass through the entire pipe and spray the polymer. The robot is set through a latch and pulled out at the other end of the pipe, repaired section. The reel, gradually winding the hose, moves the cart through the pipe. A two-component polymer and compressed air are delivered through the hose, which spins the spray cone to 10,000 RPMs. Passing through the mixer, the polymer components are mixed and sprayed with a cone on the inner wall of the pipe. Polymerization takes place in just 8 seconds. Gradually moving forward after the hose, the device leaves behind itself an absolutely impenetrable cover, covering the places of corrosion, cracks, and other damage to the old metal pipe. And how long can such a pipe still serve after coating?
Up to 50 years.
Modern cities grow not only in breadth but also in heights, and the construction of tall buildings gives another challenge to water specialists. If you deliver water in one riser, the pressure difference at the first and last floors of the skyscraper will be colossal, and this can lead even to the rupture of pipes. In this residential complex on Vorobiovi Gori, there are several high-rise buildings. The main utilities of all houses are concentrated in the central heating substation. Alexander, I understand that this is the CHS. It is unique not only for Moscow, but also for the nearest regions.
It's one of the biggest in Moscow.
And how many people do you service now?
On average, about 5,000 live in the complex, but the CHS can service up to 20,000 people.
So that's the population of a small town.
Yes.
And in your complex, there is a 43-story high-rise. So what is the difficulty of the engineering tasks that are solved here?
The question to be worked on is pressure retention, maintenance on the topmost floor. It turns out we have to make it from 3 atmospheres to 4.
That is, it turns out here on the ground floor where we stand now, the operational pressure which goes up is more than 20 atmospheres.
22 or 23.
The 43-story skyscraper is divided into 3 zones. Each is approximately 45 meters high. Each zone has its own pumping station. The most powerful unit supplying the upper floors is capable of making a water column up to 200 meters high. The maximum pressure with which water begins to rise from the basement is 23 atmospheres. As the transit section passes, it gradually decreases. But thanks to the regulators on each floor, water is already supplied to the apartments with a pressure of no more than 4 atmospheres. A greater value leads to a rapid wear of the plumbing. Utility providers of skyscrapers, as well as the pipes that they serve, are constantly in good shape because incorrect operation can cause pressure drops and, as a result, water hammers, pipe ruptures, and flooding of apartments. Pipe breaking is always a serious problem. Therefore, when designing the main water pipes, and household ones too, there is always a serious reserve for pressure. Well, for those pipes that we use in our homes, it's 16 atmospheres. And now, together with our special effects director, Leonid, we will try to find out what maximum pressure such polyethylene and steel pipes can withstand. Well, more precisely, we'll find out at what pressure they explode.
Yes.
We have a pressure gauge, a high-pressure compressor, and now we'll fill these pipes with water. Well, in order to minimize possible damage,
We'll try to burst them.
Burst them.
Yes.
Right, okay. It's full. Now, surplus here. So, tell me please, these are the connections that are made here. It's soldering, right?
Yes, with a special soldering iron for polyethylene pipes.
And this connection, it is stronger than the pipe.
Yes, stronger than the pipe. Absolutely right.
Good, so this will not be a weak spot in our experiment.
It's not supposed to, but we'll check now.
This hose has also been calculated.
Yes, this hose is designed for even more, about 300 atmospheres.
We have a small camera that records the manometer readings, and we'll be able to determine accurately at what number of atmospheres this tube. Well, let's see what will happen to it.
Yes.
Are we leaving?
Yes, we're leaving.
So, the unreinforced polypropylene pipe exploded at a pressure of 93 atmospheres. Did you expect this?
No.
Honestly, me neither. And now we'll try to test a steel pipe at high pressure. And this, it seems to me, will be very dangerous, since how many small fragments were scattered from the plastic pipe? Well, are we pouring water? All right, the pipe is full. There is one small problem. The manometer we used is designed for 100 atmospheres. And the plastic pipe exploded at almost its extreme value, but the compressor can pump up to 225 atmospheres. So, we still have hope, right?
Yes.
The manometer reached its maximum. Despite all of our efforts, we couldn't break the steel pipe. Leonid, after all, our gauge has gone off scale.
Our compressor has safety valves for 225 atmospheres, and so they worked. The compressor pumped 225 atmospheres into this tube.
The safety margin of these water pipes, well, to be honest, surprised me.
Me too.
But such a heroic resistance isn't required for sewer pipes. Flows mostly go by gravity underground. But nevertheless, the issue of possible leaks here is much more acute because the environmental safety of the residents of the city is at stake. Now we will conduct a very complicated experiment. We want to track the way of sewage through the Moscow sewage system. We have 5 such sensors here. Each egg is, in fact, a very complex electronic device. In each of them, there is a satellite tracker and GSM module, which will transfer data directly to the internet. And now on this map, we can already see the position of our eggs. We'll be able to track their movement, well, when they appear on the surface, and now we'll send all these eggs into the sewers. We'll put them in a toilet in an ordinary Moscow apartment. A few hours after we threw the sensors into the toilet, one of them began to send signals in the area of Yaoza. Does sewage still fall into the river? Judging by the satellite coordinates, this is exactly the place where one of the sensors first appeared. And it turned out to be a stationary point for snow melting. Here comes a car to unload the snow. And now, we'll try to find our sensor somewhere here. Alexei, where does this distinct smell of sewage come from?
Well, melting snow occurs due to the heat of urban sewage, so the smell comes from it.
Does snow fall directly into sewer pipes?
It gets to the snow melting reservoir, which also collects water from sewer collectors. It's mixed up there. Due to the heat of the sewage, melting occurs. Further, the mixture of sewage and thawed water enters the sand trap, where settling of suspended particles occurs, and water already without impurities is diverted to the city sewage system and then goes to the cleaning station.
Here at the snow melting point, a part of the sewage water briefly comes to the surface. And apparently, at that moment, one of our trackers managed to transfer its coordinates before it happened to get in the sand trap or go on its further journey. Well, it seems that we will have to put up with the fact that we won't find our satellite tracker here. It takes several hours to get from the toilet to the sewage treatment plant. And 2 more of our sensors did not keep us waiting. The latest data which we received from our satellite trackers came from here. Here is the first stage of wastewater treatment. Namely, all large garbage is removed from the sewage system, which, for various reasons, turned out to be in it. Excellent smell. Sewage is filtered through gratings and rags. Paper and kitchen scraps are raked and dropped onto the conveyor belt. Most likely, our sensors were caught at this stage and, apparently, along with other garbage, already fell under the press. The rammed waste is then disposed of at the landfill. Well, the drains are passed through sand traps and sent here to closed sedimentation tanks. Then biological water treatment begins. In these aerated ponds, bacteria decompose organic contaminants, purifying water. What in nature lasts for weeks, here occurs in a matter of hours. The most favorable conditions are created for microorganisms. After secondary sedimentation tanks, where water is separated from bacteria, it is already considered to be practically pure.
For comparison, we show you tap water. This is the water that we drink. And our purified water, the quality of which we get after purification. You can see the tap water isn't particularly different, the same.
Well, the most important thing is that it's different from this water, right?
Yes.
At the last stage of treatment, the sewage water has such a poisonous green color. But this is not the result of the action of any chemicals. More than 6,000 of these quartz lamps installed in 17 channels below me complete the stages of sewage water treatment. Ultraviolet eliminates all pathogenic flora. Well, or simply speaking, disinfects the water. Strangely enough, the most powerful ultraviolet killing bacteria doesn't cause a feeling of discomfort in small fishes. Here they eat, live, reproduce, which allows us to judge the quality of purified water. Well, it's time for sewage water to return to nature. Without it, the lower reaches of the Moscow River would drop by a third. It takes 14 hours for dirty sewage to pass through all the treatment facilities to get to this channel flowing into the Moscow River. And it's worth noting that the water here is chemically and bacteriologically even slightly better than water in the river. Due to the territorial and climatic features of our country, thirst isn't a threat, but the water balance is easy to break. Water not only gives life, but it can also bring death. And only a careful attitude to water at all stages of its use will save us from serious problems in the future.